Okay, hello everybody. This is Mrs. McConnell. We are going to go ahead and get started with Chapter 1, this first section, 1.1, which has to do with displaying data and analyzing categorical data. Okay. One thing you'll notice in statistics is that there are a lot of vocabulary terms. And it's crucial that you understand what a lot of these terms are referring to, okay? So when we talk about statistics, that's what you're going to put here on the first blank. Statistics is the science of data. A lot of times it's referred to as the study of variation, okay? Variation is just how something differs. Statistics is really all about analyzing data. And so when we talk about data analysis, that is the process of taking information, organizing it in some manner, displaying that information in some manner, summarizing the data, and then asking questions about the data. And this little picture right here does a really good job of summarizing what the statistical process is, okay? What statisticians often are interested in is they want to know something about a population, but a lot of times that population is way too large for them to be able to survey everybody in the population. And so what they end up doing is through a random process, randomly selecting a smaller group from that population, which we would call a sample. Now, if you have a smaller group to deal with, a smaller group of data, then you could kind of organize that data, display it, summarize it, and maybe draw some conclusions. So your sample, we would perform what's called descriptive statistics. And descriptive statistics is much more than just mean, median, and mode, but you would look for you would look for trying to find the center of the data. Maybe you would look for some unusual values, if there's any outliers or anything like that. You would look for what's the spread of the data, how spaced out is it, and what's the shape of that sample. Okay, what's the shape of that sample there? Okay, and you'll notice that this makes the acronym CUS, which we'll talk about more in the future. Okay, but when you have that small sample and you've kind of done an analysis of the small sample, we then use what's called inferential statistics, which is when you infer or you're kind of drawing a conclusion then, a generalization about the population based on your sample. It's not always the correct generalization, but you're basing it on the sample which you drew from the population. Okay, so that's kind of in a nutshell what statistics is. We're going to take a look at this term called individuals. What individuals are is they are objects described by the data set. Okay. So it doesn't have to be people, okay? It doesn't have to be people. But individuals are typically, who you're collecting the data from or what you're collecting the data from. And then a variable is any characteristic of an individual. Okay, so I might choose to randomly sample 50 students from Dover High School. I might ask each of them, what was your GPA last year? The individuals would be the 50 students that I selected from Dover High School, and the variable would be the GPA of each of those students, okay? So there are two types of variables, okay? Two types of variables. One variable could be categorical in nature, and if it's categorical, it places an individual into a specific, and then here's the key word, into a specific category, okay? Let me give you some examples here. An example might be colors, maybe car models, maybe categorizing the size of a drink as being, say, small, medium, or large, okay? Whereas a quantitative variable, this takes numerical values, okay? Numerical values, and then this is important, for which it makes sense to find an average. And here's what I mean by that, okay? Miles per gallon, okay? Obviously, that is numerical in nature, and you could take all of the cars that you were to have in your sample, and you could calculate from all of them the average miles per gallon. Test scores, you certainly could calculate the average test score from your sample, okay? You could also do the size of a drink like I had illustrated in Categorical, only you could say, well, the small is 12 ounces, the medium is 16 ounces, and the large would be 20 ounces, okay? Here's where a numerical value would not make sense, okay? If we were talking about, say, a zip code, okay, think about a zip code. It's a 5-digit number that's really more like a category than it is some type of numerical value where it would make sense to say, I have these 5 different cities, and this is what the average zip code was from those 5 cities. That doesn't make any sense to add them up and divide. So in that case, a zip code or even an area code for a phone number, it would fall more as a categorical variable than it would a quantitative variable. That's why it's not any numerical value. It's a numerical value where it would make sense to find an average, okay? All right, so a variable generally takes on many different values, and what we're interested in is stats, is we are interested in how often a variable takes on each value, okay? Takes on each value. And that's what a distribution is, okay? A distribution tells us what values or categories, okay? What values or what categories, if we're talking about a categorical variable, a variable takes on and how often it takes those values, okay? So a distribution is what are the values of that variable, and then how often do they occur? Like when you went out and say you surveyed 50 Dover High School students, maybe 10 of them had a 4.0, and so 4.0 is one of the values of the variable, but then somehow we need a way to be able to display that showed up 10 times in our sample. Okay, that's what we mean when we talk about a distribution, showing what the values were and then how often they actually show up. Okay, so how we're going to explore data, okay, we're going to start with each variable, okay, we're going to start with each variable by itself, and we're going to study the relationships among the variables. And we want to start with a graph, okay, because the graph is a great way for us to add and show numerical summaries, okay. By the way, there are lots of different distributions in this chapter. We're going to focus on describing the characteristics of a distribution of sample data, but then in the next chapter, we will look at something called a normal distribution, okay? Okay, one more page that we're going to wrap up here with this first video. Okay, you can see here we have in this example of the U.S. Census, it says there were 10 randomly selected U.S. residents from the 2000 census. So each of these rows represents a person, and you can see there are all different sorts of variables that are collected from each person, but we have 10 rows here. Okay, so the first question is, who are the individuals in this data set? okay? And we would say, well, they are the 10 randomly selected U.S. residents from the 2000 census. Okay. Here's one thing that you're going to get used to very quickly in statistics is this is very much not just a math class. It is very much a reading and writing class. It is all about communication, and so it is very critical on the AP test that these graders, they're called readers, that they understand the context of what you're talking about, okay? And so you'll notice how descriptive I was here. The individuals are the 10 randomly selected U.S. residents from the 2000 census, okay? Let's look at part B. What variables are measured and identify them as categorical or quantitative, and in what units were the quantitative variables measured, okay? So I'm going to make a couple different lists here. We're going to call this our categorical variables. Okay, over here, this can be our quantitative variables. Okay, and we're going to list these. I'm just going to kind of go through here. The first one, state. Okay, well, that would fall in categorical. It looks like the number of family members would be quantitative. And how is that measured? That's measured in number of people. Okay. Age, that would be quantitative. Looks like that's measured in years. Gender, that would be categorical. Marital status, also categorical. Oops. Total income, okay? Total income, that's back over here on quantitative. That would be measured in dollars. And then travel time to work is in minutes, okay? All right, it says describe the individual in the first row. So we're talking about this person right here, okay? If we were to describe that individual, we could say that she is a 61-year-old, it doesn't matter the order you go through this here, but she is a 61-year-old married Kentucky resident with a total income of $21,000 and lives 20 minutes from work. And I think I left one thing out. She has 2 family members. Okay, I'm just going to scroll back so that you can kind of see that with this here. Okay, she has 2 family members there. Okay. All right, so the last 2 questions here. What is the difference between categorical and quantitative variable? Well, quantitative variables are numerical only, okay? But I'm going to make a note here. Averaging must make sense, okay? It's not just any number, okay? And then categorical variables sort, they can be sorted, we'll say sorted, by the type or the characteristic. And I'll just say it doesn't make sense to average. Okay, and that's why we would say zip code would fall in a categorical variable. And here we are. Do we ever use numbers to describe the values of a categorical variable? And do we ever divide the distribution of a quantitative variable into categories? Okay, yes. Okay, we can use numeric categories. Okay, so this would be a categorical variable, and the examples could be, it could be a zip code, it could be an area code, okay? And yeah, So we can totally divide something that's numeric into categories for sure, okay? This brings this first video to a close. The next video you can see in your notes page here is listed for video B for 1.1.